Okay, we've moved on to hyperbolas, and hyperbolas are rational functions. And the definition of a hyperbola is that of all points, it's a difference from two distinct points called the foci. So a hyperbola has two what's called branches, and these two are the branches, and they could be either vertical or horizontal. The other characteristic is that they do have asymptotes, and the asymptotes meet at what is called the center, and the center of the hyperbola is the point h comma k. That would be the center. So we have the center there. The vertices are kind of these relative max or mins, and we label the vertices with the letter V. The center we're going to continue labeling with the letter Z, because the letter C is still the distance from the center up to the foci, which are going to be labeled with an F. So the distance from the center to the foci is C. The distance from the center to the vertex is still going to be A, which is the same as it is for an ellipse. So you can see the C and the A. And then I'll show you what B is in just a minute. So the vertices is the 2 points where the line through the foci meet the hyperbola. So the line through the foci touch the hyperbola, the 2 branches. The transverse axis is the line segment connecting the vertices. So the transverse axis is this little axis in here, and you could either have the transverse axis being vertical, or you can have the transverse axis being horizontal. Those are the 2 cases. We have the horizontal and the vertical case. And the conjugate axis is the line segment through the center, which is perpendicular to the transverse axis. So I will highlight that in green. The conjugate axis I'll do in green is the one up here, and that is the distance where this distance here is our B. So the conjugate axis has length 2b versus the transverse axis, which is the one between the vertices, and the center to the vertex is A, so the length of the transverse axis is going to be 2a. And we're just going to call them horizontal and vertical. And then the center is the midpoint where these 2 axes meet perpendicular. So what we're going to do to graph it is we're actually going to find this little box. And to do that, you find the center of the box. Then you're going to go over A to get to your vertices. And then you're going to go up B. And then you'll be able to draw in this box. And at the corner points of your box, we're going to draw in our diagonals. And then we'll be able to graph our branches that approach our asymptotes and meet at the vertex. Okay, so let's scroll down a little bit and talk about the 2 equations that we're going to have. Okay, so we have the 2 cases where the transverse axis is horizontal versus the transverse axis is vertical. Okay, so here you notice that this equation is very similar to that of the ellipse. However, the important thing with hyperbolas is that it's a minus symbol. The other thing that is different is notice that the a squared is always first. With the ellipse, you put the a squared under the 1 so you know if it was horizontal or vertical. But when it's horizontal, the x comes first, which is under the y, the a over the a. And if it's vertical, the y comes first, and a is down there. Okay, so what you need to know more importantly is that it's a negative sign. If y comes first, you go vertically. If x comes first, you go horizontally. You have your transverse axis. Okay, so let's go ahead and fill out these things. The center is h comma k, and that is the same as it's been. The vertices, remember if you have your axes, the center is at hk, h comma k. So to get to your vertices, you went over h, and you have to go to your vertex. Remember the distance from the center to the vertex, you have to go over a more. So it's h plus a, and to get to your vertex over here, you have to go over h and then subtract a. So it's h minus a. So the x-coordinate is h plus or minus a, and then the same k. However, when the transverse axis is vertical, the center is at h, comma k. So the x-coordinate is h, and then you move up and down. So it'd be k, and then to get to the vertex you go up a, and to get to the other vertex you subtract a. So it'd be k plus or minus a, and those would be the two vertices. The foci would be similar, except instead of going over a, you went over c. So it'd be h plus or minus c, comma k, and h, comma k plus or minus c. Because again, you go over h, and then you go up k, and then to get up to the foci, you go k plus c, and you go k, and then subtract c to get to your two foci, which are shown. So the foci and the vertices lie on the transverse axis, and for the hyperbola, we have that c squared is a squared plus b squared. So remember with ellipses, it was a squared minus b squared, but for the hyperbola, it's a squared plus b squared. So again, we're going to do similar things that we did with the ellipses, but we're going to find the third of a, b, and c differently. Okay, so let's scroll down here and do example number 1. Okay, so here we need to find all the things for the hyperbola and sketch its graph. We know it's a hyperbola because it's a minus sign in the middle. The ellipse and the circle were pluses. The x squared term comes first, which tells you that the transverse axis is going to be horizontal. If the y squared came first, then you know that the transverse axis would be vertical. Okay, so this first number is always going to be a, so my a squared is 9, which tells me that a equals 3. This number is always going to be b squared is 25, so b equals 5. And we can use the formula that a squared plus b squared is c squared. So 9 plus 25 is our c squared. 9 plus 25 is 34, so c squared is 34, or c is the square root of 34. Now that's close to 34 is close to 36. So I know that the square root of 34 is just a bit less than 6, which we just need to know about what it is for graphing purposes. Okay, so moving on over to the graph, we know its center. So because it's x minus 0 and y minus 0, we know that the center is at h comma k, which is at 0, 0. So I'm going to plot my center. And then I'm going to plot my vertices. My transverse axis is horizontal, so I'm going to go horizontal to get to my vertices. And I'm going to go 3 units. So it's at 3 and at minus 3. So I plotted those, and those are my vertices, so I'm going to label those with V's. I can go to my foci. So my vertices, since I have to find these, they're at plus or minus 3 comma 0. Right, there's 2. You can write it like 3 comma 0 and minus 3 comma 0, the two equations, or you can just write plus or minus 3 comma 0. We can find the foci. Remember the foci was c units away, and c is square root 34. So I'm going to go over square root 34, which was a little less than 6. So that's where my foci are. You go minus 1, 2, 3. Have my other foci. So the foci are at plus or minus square root of 34. Comma 0. Again, it's at plus square root 34 and minus square root 34, and I'm writing the exact value here. I use the approximate for the graph. Okay, so now we have the vertex, and I know roughly that it's going to have these 2 branches. and my foci are going to be inside the branches. So I'm going to have to create my box and do my diagonals. So in order to do my box, I know that my box went over A units from the vertex, and then it's going to go up B units from the center. So I have A units and A units from the center to the vertices, and then I'm going to go B units, which is 5 units up and down. So 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5 to -5. And so I'm going to have this little box, which I'm just going to draw in with a dotted line, and it connects my vertices. Okay, so the box goes up B units from the center, down B units, and left and right A units. So your box will always be made up of 2A and 2B. And then you're going to draw in the asymptotes of your graph, and the asymptotes of your graph are by drawing your straight line that connects your two vertices, and it goes through the center. In this case, our center is at the origin. So we have our two vertices. So we're going to go ahead and plot the two asymptotes that go through the corner of your boxes. Okay, so it's always going to go through the corner of your boxes and at the center. And then we can draw in the final graph. So now what we're going to do is we're going to draw in the two branches, and the branch goes through the vertices and it approaches your asymptotes but doesn't touch it. And they should be C-like shapes. And you do have two of them. So it touches your vertex, and the vertex should be kind of the leftmost spot and the rightmost spot of each branch, or if it was an up-down one, then it should be the bottom and the top of those branches. It does have arrows, and I am looking to see that it approaches your asymptote, touches your vertex. Okay, so we had to find the center, the vertices, the foci of the hyperbola, and sketch. So we found the center, the vertices, and the foci. So I'm going to box those in, and we had to graph, and that is everything for this problem.